keynote speaker, our opening keynote speaker, and our greatest pleasure today is to have with us Scott Chacon, former co-founder of GitHub and co-founder and CEO at Gitbutler, a next-generation version control client. Scott helped grow GitHub from 4 co-founders to 450 employees over 8 years, eventually being acquired by Microsoft for $7.5 billion. Scott is also the author of ProGit, a fully updated guide to Git and its usage in the modern world. In unrelated news, he holds a WSET Level 3 certification in wines and spirits and owns a dog rescue outside of Berlin. Scott will be talking about open source 2.0, the text editor's last laugh. Scott, welcome to stage.
Let's see who has the last laugh, huh?
Hello, everybody. It's nice to be here. Oh, I got some highs back. It's nice to be here. Thank you for having me. Thank you for inviting me to Greece. I'm very excited to be here. Today, I want to, oh boy, sorry. I'll try not to do that one again. Today, I'd like to talk about, actually, the text editor's last laugh. I want to talk about text editors, but more broadly, I think, I want to give a little bit of a keynote-y type thing. This isn't going to be super, super technical. This is more like start thinking about some stuff. And I mostly want to talk about questioning your tools. So I think as software developers, I assume most of the people in this room are software developers, we don't spend enough time questioning the tools that we use every day. We're working on something specific. We have a goal, we have a job, we have something to do, and we use the tools that are given to us, the tools that are presented to us, and we don't really stop and think about them and get frustrated by them and figure out what would a better way of doing this be. And it can be a little bit dangerous because once you start doing that, you start getting frustrated by all of your tools all the time. But I think that's actually a better place to be because you can move forward faster. You can build new things. You can build more interesting things. You can become more efficient in building what we're building every day. So the first thing that I want to do is give you a framework that I don't know if we came up with it, but we certainly adopted it very heavily at GitHub. And it's something that in the startups that I've done since then has been very valuable to us. I think we use this tool pretty much every day. And it's a concept of first principles. So some of you may have heard of first principles or 5 whys or something like that. If you haven't, I want to go over it relatively quickly because it's one of the most valuable tools for questioning the tools you have or figuring out how to design interesting products that you're building, no matter what it is that you're building. So I want to talk about what first principles is and how I use it every day, every week. So first principles comes from physics. It's a concept in physics, which means a first principle is a basic concept or an assumption that we know to be true that's not deduced from anything else. So there's no other assumptions that this is built on top of. And if you think about everything that you're doing, everything that you're building, it's built on top of other things. It's built on top of assumptions. And at some point, you stop questioning those things. And so this is a tool to help you question those things, help you come up with more interesting questions, more interesting answers to what it is that you're building, what product it is you're designing. And so I want to talk a little bit about how to do that very quickly. So the key tool in first principles is the question why, right? So how many of you have or have had kids around the age of 3? Yeah, okay, somebody laughed because they understand that this is a 3-year-old's favorite question because 3-year-olds are physicists. They're little tiny physicists that try to go through and figure out how the world works around them. And so what I ask you to do is to become your own 3-year-old, to become your own little physicist. And the way that this tool works is it's very easy. You just keep asking this question over and over and over until your parents get mad at you, until the answer becomes because. So I want to give an example. This is an example that I'm stealing from a very famous physicist called Richard Feynman, who did an interview at some point, and he told this story about trying to explain this concept a little bit of what it is to know something, what it is to understand sort of the basic meaning of something. And he said, let's say that you're an alien and somebody says, hey, Aunt Minnie's in the hospital, right? And so you say, why? Why is Aunt Minnie in the hospital? This is an interesting question, right? You want to know how serious is it? What happened to her? Did she get in a gang fight? Like, what happened with Aunt Minnie? And then they say, well, she fell and broke her hip. So it's like, okay, well, Aunt Minnie's a little bit old. Maybe that makes more sense than her getting in a gang fight, right? Like she fell and broke her hip. That makes sense. Okay, it's not that serious probably. It's not a head injury or something. She fell and broke her hip. She's in the hospital. Fine. Why? Why did she fall and break her hip? She slipped on some ice. Okay. Now, most of us, I think, would stop here. And if you can put this into a product perspective, you can think about whatever product it is that you're working on every day. This is probably generally where you stop, right? Because you know why she slipped on some ice, because ice is slippery, right? Like it doesn't make any sense unless you're 3. When you're 3, you say why, right? And then as a parent, you're like, because, like just because, right? But most of us have this assumption. We understand why you slip on ice because we've all slipped on ice. We have an assumption that we're basing something on. You don't need to keep asking why, right? It becomes exhausting. It becomes as exhausting as having a 3-year-old that's asking you this all the time. But what I want to say is, in the context of your product, in the context of whatever you're doing, become a 3-year-old, keep going, right? If you keep going, anything becomes interesting. It really doesn't matter what it is. If you ask why enough times, anything becomes interesting. You start thinking about things in a way you hadn't before. Because to explain a why, you have to be in a framework where you allow something to be true, unquestioned, right? And so let's question it. If you undo that assumption and you start questioning it, then you can get to really interesting things. So she slipped on some ice. Why did she slip on ice? Because ice is slippery, right? Okay, fine. But why? Why is ice slippery? Actually, I want to do a quick show of hands. If you think you could explain, I won't ask you to do it in front of the audience, but if you think you could explain why ice is slippery, raise your hand. It's not that many people. Or there's not that many people who want me to call them out and have them come up on stage and explain it. But the reason why, it's an interesting question because ice is a solid, right? How many solids are slippery? There's almost no solids that are slippery. If you have very, very smooth concrete or metal or something, it's not slippery unless there's water or oil or grease or something on it to cause this loss of friction. So why is ice by itself slippery? Well, that's actually a really, really difficult question to answer. And I Googled this, and I came up with a paper that was published last year, right, where in the abstract it says, the origin of ice slipperiness has been a matter of great controversy for more than a century, but an atomistic understanding of ice friction is still lacking. The answer is we don't really know, right? We've been trying to figure out exactly at an atom level why ice is slippery for hundreds of years, and none of us actually know why this is. We have a general understanding, right, which is, if you're interested, is that water expands. Water is one of the only liquids that expands when it freezes. Almost every other liquid contracts when it gets cold. Water expands when it freezes. When you put pressure on it, that melts it for a very, very small amount of minuscule seconds, and that creates a water surface on top of the ice, and so it becomes slippery, right? But that's why no other solid really does this, right? Only water does this. But this is an interesting question, right? And so what I want to point out is that you can go from something very mundane, right? Something some product that you're working on, something that you're working on, and you can ask why enough times until you get down from Aunt Minnie's in the hospital to an atomistic understanding of ice friction, right? Like, that is the path that you can always go through, and it doesn't really matter what you do this to. So what I want to do as an example, so my company, Gitbutler, we have this new startup, and we're kind of going to first principles on version control. I could probably give a talk on that, but I'm not going to do that. I want to talk about something else that has been coming up in the news a lot that I'm very interested in, which is text editors. I want to do this for text editors. And the reason that this is coming up a lot is because of AI, right? So we have these large language models, we have generative sort of code tooling that we can use now, and none of us really know how to use it exactly. I think we're all using it in different ways. None of us know where this goes. So what I want to do is I want to question the text editor as a tool using these principles as partially an example, but also to get you guys thinking about, get frustrated with a specific tool that you have. And it doesn't really matter which one. It doesn't matter if it's version control, which is kind of what we're doing. It doesn't matter if it's text editors, which is what other companies are doing. But I find it an interesting process. And so I want to use this as an example for how to apply this type of tooling or this concept of first principles and why it's valuable. So This is one of the first text editors that I could find a screenshot of. This is obviously an emulator. This is the Tico editor that was originally written almost 40, 50 years ago, right? 1962 was when the first release of this is. Now, obviously, in this particular example, he's editing HTML, so I don't think that this was done in 1962, but they're running an emulator. But the interesting thing about this is how little this has changed. Raise your hands if you use Vim or Emacs in this room. So how massively different is this tool that we're using from 40 years ago to the tool that you're using today, right? Like, I use Vim. It doesn't look that much different than this, really, right? Like, a little bit. There's nicer fonts, and there's sort of colors. There's a ton of little plugins you can put into, find your files or go through your tree or whatever. But like, at a very fundamental level, what we're doing is we're opening files. Those files tend to be a specific type of length, not much bigger, not much smaller. And we're doing a lot of stuff on the command line. So this is what computers looked like in 1962, right? This is when text editors were first invented, when we first used these as tools, our computers looked massively different than, we have iPhones in our pockets that are much more powerful than this entire room was then, right? But we're still using a very similar type of technology to build the software that runs on them. And I find that interesting. So I want to go through some first principles for text editors. We all use a text editor. I think that's a fairly general, statement that is probably true for everybody. I don't think anybody here is coding not in some sort of text editor. So why? Why are we using text editors? What is interesting about a text editor? What is valuable about a text editor to what we're doing? You can come up with any. There's lots of different ways that this conversation could go. This is the way that it kind of went in my head when I was writing this. But I think it's an interesting example of this, right? So software is text. And humans have to write that text, and so we need some sort of tool to do this. Interestingly, if you have an LLM, tool that you're using to sort of generate a file or something, it's not using a text editor, right? It's not opening up Vim and using it to edit something. Text editors are a very human invention. It's a tool very specifically for humans, not necessarily for getting code into a file. It's for humans to get code into a file. So, is that true, though? Like, do we need a text editor? Because software is text and humans write that text. Humans don't always have to write that text. If you've used LLMs, if you've used tools like Wix or Framer or Softer or something, right? You're writing code. You can get the same website written if you're opening up a text editor and sort of writing React by hand, or if you're using something like this. At the end of the day, you still have a website. It still does the same thing. So that's not really a true statement, right? So let's work on that a little bit, right? Okay, we need text editors to write good or fast software, right? Because maybe you want to have it be more customized than Wix or than Framer or a no-code tool that you might be using. So is that true, right? Is that actually a true statement as well? Now there are some AI tools that you can use for this. If anybody's used like V0 or GitHub X or something like that, you can describe what you want, and it can come up with something very customized for you, right? Not necessarily what the no-code tools have. And this is an example that I did a couple days ago, where I say, okay, write a chat application. It comes up with a couple different examples, and you can regenerate it, and you can go and look at the code, and it has HTML or it has React components. So you can write code without using a text editor today. So this also isn't particularly true. This is also Codex, which is a component IDE that Wix has that I found kind of cool. You can also go in and customize the text if you want to, but it's a little bit different than a text editor that we would normally be using, right? Okay, so that's not exactly true either. So to write complex systems, we need a text editor. So I think that's generally true, right? If you want really complex systems, you can't have sort of an LLM generate a whole Rails app with all of the files and have it run and debug it and things like that. So if you want to write a complex system, you need a text editor. So why is that? Why do we need a text editor to write complex systems? Well, I would argue that we need a text editor to write complex systems because our frameworks, the way that we write software, are based on having a lot of complex interconnected files, right? If you go into a software project and you're a new member of the team, it takes you a while to onboard because you have to go through the structure. You have to know there's hundreds of thousands of files probably, right? There's millions of lines of code in some cases, right? If you get a job at GitHub today and you go in and look at the github.com code base or something, it's huge. It's very, very difficult to go through and figure out how to start adding one thing into it. So, I mean, this is just an example of a small project, right? This is the Gitbutler code base, just the Rust files, and we have hundreds of Rust files for a relatively new project. So this is how we write software. And so you need a text editor in order to do this. It's relatively difficult to contribute to a code base if you don't have a text editor to go in and be adding these files. This is kind of what the dependency graph of our modules look like in Rust alone, right? And so if I want to add to some part of the system, I need to figure out where that is, what file that is. And I find this really interesting because we can ask a couple different questions of this. Why is this? Why are our systems written this way? Why do we write code? Why do we generate and produce code this way? Why not just have one great big huge file, right, and have all of the code in that? Because our computers don't care, right? Our compilers don't care. Whatever actually executes the code doesn't even know probably how many files are in it, right? It compiles it into something completely different. So we could do this all in one great big huge file, but we don't. Why? Like, why do we not do that? It's because we're human. That's hard for us to do, right? It's hard for us to open up one huge file and figure out where in that file is the bug, or where in that file do I add a new part of the system. And so we use text editors for that. But we can ask the opposite question. Why not have every method, every function, every tiny snippet of code in our entire code base in a separate file? Why not have hundreds of thousands of files with one method, one small piece in each individual one? For exactly the same reason, right? Because we're human, and then it would also be difficult to find that thing. And so we try to find a balance, and we use a text editor to navigate the balance that we've found from the weaknesses that we have as human beings. So, why is this, right? Why are our frameworks built this way? And I would argue that it's almost a reciprocal argument, right? I think our frameworks are built this way because the tools that we use and the limitations that we have as human beings are built around this, right? This is why our frameworks look like this, because we have a text editor. Why do we need a text editor? Because our frameworks are built this way. But let's reimagine this a little bit, right? What if human beings weren't writing all of the code? What if you did have an LLM? What if you did have something that was specifically trained on the framework or on the thing that you were trying to do? What would it look like if human beings didn't have to produce every line of code that was written? Or you could just see a very specific, like not just the file. Let's say I'm not just opening the files in the system that I'm trying to do. I'm just being presented with the functions that are relevant, and I can look at those and I can edit those, or I can update those, right? What would that look like? More interestingly, one of the tools that we have, as I keep talking about, is these LLM systems, is the AI systems. They are non-deterministic, right? Actually, human beings are non-deterministic as well. We're just not very parallelizable. We're not very scalable in parallel, right? So you guys are all software developers. If I gave everyone in this room the exact same thing to write, you would all write that thing differently, right? It's not like a deterministic system. It's not like we would all have to write our code in exactly the same way. Maybe the output would functionally do the same thing, but I can all ask you to do FizzBuzz or whatever, today, and all of you would solve it slightly differently. And LLMs are the same thing, but what's interesting about that is, and something that I haven't seen in sort of the AI landscape, is a system that takes advantage of this, right? It would be nice to say, here's what I want solved, write 1,000 of them and test all of them and try to figure out what are the best 2 or 3 and show those to me and let me choose which ones are closest to what I want and maybe do the last mile, edits or fixes or something. And in that case, if we have systems that are doing that, if that comes up with good code that we can verify, are we still using text editors, right? Does it even make sense with that tool set to use the tool sets that we're using today? And I think that the answer is no. I don't think that we're going to be using, with the new tools that we have, with the LLMs that we have, with whatever's coming in the next couple of years, I don't think that writing code in a text editor the way that we've been doing it for the last 50 years is exactly how we'll be doing it in the future. So, as sort of one last thing, I want to go back and look again at text editors as a way of questioning your code, right? And this is another thing that I think is really valuable, is not just going down to first principles of what does this thing do, but also what is it not good at? And this is sort of the second tool, which is to become easily frustrated, right? Whatever it is that you do as your job, as software developers, the best software developers, I think, are the ones that are the most easily frustrated. I got into software development, I think, because I was doing data entry at a company right out of high school, and I was putting all of these numbers into, I was doing some reporting or something like that, and it got very repetitive very quickly, right? Because you're doing the same thing over and over and over and over again. And I think why a lot of us got into software development is we don't like doing the same thing over and over and over again, and you can write a program that does that, right? And then you figure out what is the next thing that you're frustrated with that you have to do repetitively, and you write a program to do that, right? I think that's for most of us what we really love about this job, about the creation aspect of what we do. And so I think it's interesting to look at the tools you have and be easily frustrated by them and figure out what is it not good at. And it can be frustrating as well, because then you're more frustrated all the time when you're doing stuff. Now that I'm paying attention to this, I'm constantly frustrated by my text editor. But I'm working on something else, so that's not what I want to do. So part of this is, please, if you're looking for a project, help me with some of these things so that I can use that tool and maybe pay you some money for it or something. But what are text editors not good at, right? What becomes easily frustrating? Again, do this with your product, sit down and do it and figure out, what am I easily frustrated with here? Some things that text editors are not good at. It's not good at groups of files, right? I find this constantly frustrating, because if I'm working on a Rails app or something, right, which tends to be, or a Rust app or something like that, and I'm working on some specific system, I don't want to search for the file. I have to memorize which files I need to open, right? Or I need to figure out there's usually 4 or 5 or 6 files that I need to edit. But they're always a different 4 or 5 or 6 files, depending on the system that I'm working, depending on the feature that I'm trying to implement. And it's not very good at saying, hey, I see what you're trying to do. Here's a list of possible files that seem to be edited at the same time, or when you're in that code, here's some examples of some other ones. Do you want me to open all of those and kind of have them in a buffer for you so you can switch back and forth between them fairly easily? I have to manually do all of that all the time. So it's actually not that good, even at doing the things that it's built for as far as file management. It's not always great at go-to definitions. This is something I've used for a long time. It's like C tags and Vim even, right? Of saying, hey, here's a function I'm looking at, go to where this is defined. Sometimes you can set it up, there's some work. It's not horrible, it does do it, but it's not very easy out of the box most of the time. And it's not always perfect. I think finding a method, I mean, you have to do a string search and figure out. I actually do this a lot. It's kind of related to the other one, where I'm seeing that there's some function, and I want to go to where that function is defined and figure out how it's implemented. And I can search for the function thing, but then I have to figure out what is the difference between all the places it's called and where it's actually defined. So then you have to have tree sitter or some sort of parser or something that kind of helps you figure out where's the definition of this versus an invocation. This is one that I do a lot. I don't know if you guys work on web apps, but if you're on a web app and you're looking at something and you're like, I need to change this component, and you weren't involved in that component in the first place, and you're like, hopefully there's an English string in here somewhere that I can search for to figure out what is the React component that's actually putting this out, because otherwise it's a little bit difficult to figure out the definition, where is what is this component that is actually being done, right? If it's a time thing and there's nothing to search for, sometimes it's very difficult to find. It'd be nice to just click on the thing in the web browser, right, and have it open it up so that I can see, okay, this is something I need to edit. And now we're getting into stuff that, most of these things you can get around, or it does some version of this, but some stuff it doesn't do at all. So explaining code, right? How often does this happen? You're working on a function, you didn't write it, it has some problem, you're trying to not mess it up further, right? But you don't really have context on it. And so you want to say, what is the story of this function, right? What was the issue that somebody was working on when they implemented it? What was the story that was around it? What other code was touched when this was done? Was it erroring before this and there's some fix? The best really we have is git blame, and some of us have this sort of in our editors as well. But most of us actually probably don't even know how to use git blame very well, right? How many people, I'll do one more show of hands. I really don't love doing show of hands stuff, but how many people know how to make git blame ignore white space changes? Okay, 5 people in this room? Right. So if you go in and you have a really cool coworker that decides that you should switch from tabs to spaces, and reformats every file, now that person comes up as blame in every single file in your entire code base, right? It's actually relatively difficult to walk back and figure out, okay, who actually did this? Or, even worse, if you copy a function into another file, now the person that did the copy is the owner of that function, not the person who originally wrote those lines. And Git can get around that as well. Does anybody know the flag to make Git get around that, to follow function movement? It's -C, but you have to do it 3 times. So you do git blame -W for white space, -C, -C, -C. It's the weirdest invocation I've ever seen, probably, but it's a way to make git blame actually a little bit better. But let's look past that, right? It's not just about who's the last person that edited this line. It'd be much more interesting to say, tell me a story, like as though I had a senior developer that originally wrote this and could tell me the story of why it's written this way. That's actually very hard to do, right? You have to find that senior developer that implemented it. Maybe they left the company, maybe they don't like you, maybe you don't know who it is, right? But like, how nice would it be if our text editor, if you could say, tell me not just what this does, but tell me why this is here, right? Like, what was the zeitgeist of the company, of product development when this thing was implemented? I would love that, right? And we probably have the data and the tools to do that, but they're not all put together yet. Yeah, explaining a system is kind of similar, right? Like, if I'm in a function, I want to know the system that it's around. I want to know what is this part of the product, right? And that's also very difficult to find. And it's so difficult, it takes so much time that most of us just don't do it, right? We just make assumptions, maybe ask a question in Slack. If it's too much time, we'll just, maybe break it, right, on accident, because we didn't really have the concept about that. And you can keep going down this, right? Where code errors, where code is slow. Like, there are other systems that run this. It'd be nice to see, like, if I'm on a line, how many times has Sentry complained about this line in the last month, right? Or if I edit it, like, did that make those numbers go down or not? That is not where we're editing code, but that is incredibly valuable and incredibly useful to what code I'm editing. And so on and so forth. There's lots of different things, right? The point is that we all use text editors. It hasn't changed that much in the last 50 years at a fundamental level. And there's so many things that we do every day that we could be so much better at our jobs if we cared a little bit more, if we were a little bit more frustrated in this one particular tool. And I could give talks on pretty much every tool that we use. I find them, like, version control is another good example. How much has that really changed since RCS or CVS, right? It is a little bit different, but is it fundamentally different? Is it fundamentally rethinking kind of what we're trying to do with versioning code, with managing our source? So, let's imagine a future, because we're all going to have to be programming. I mean, most of us, I assume, are going to be programming in 5 to 10 years still, but we have new tools. We have new innovations, especially with the large language model stuff. What can this look like? What might this look like? Let's prepare ourselves for this. Or, in some of your cases, let's write parts of these systems. So I think what's interesting about LLMs right now, about code generation right now, if you're using something like GitHub X, if you're using something like OpenAI, ChatGPT or something, and saying, write me a function for this, I think what's really interesting is that what it does right now is it writes you code that was in a framework or in a programming language that was specifically developed around human weaknesses, right? So when we're using typed languages, when we're using Ruby, right? When we're using, or TypeScript, like they're developed for different things that humans were good or bad at, different things that humans like or don't like. But there's not a language, there's not a framework, there's not a Rails, there's not a Django, there's not a whatever it is that you're using. None of those things exist that were optimized specifically for large language models, for the things that large language models are good at, and not the things that humans are good at. We're making large language models do things that humans used to have to do, and saying, oh, it's not good at these things, right? But that's not what they're meant to be good at. They can be better if there were languages or if there are frameworks that were built specifically for the things that they're strong at, and around things that they're specifically weak at. So on and so forth. The other thing that I find very interesting from this perspective, going down the route of what are humans good at, what are humans not good at, is we want systems that are to some degree deterministic. We want to write code that pretty much always executes in a known way, right? To have tests that execute in a known way, that if a user comes to the website that fits a specific profile, they see something that looks very specific. And they always see something that looks very specific, so that if there's a problem or something, we can debug it and we can recreate it. But one of the things that's very interesting is that we have this sort of limitless generative tool set now that we can do anything with. What if the user interfaces that we use in the future change every time that we interact with them, right? What if the component, I mean, this is actually, ChatGPT is this, right? It's a very simple outline for a user interface, but all of us get a different user interface experience every time that we're using it. But what if that goes into components? What if that goes into website? What if it goes into HTML? What if it's generating a new interface for me every time I'm trying to do anything and it's very specifically customized to me? It's a pain in the ass to debug. It's a pain in the ass to figure out what it's doing and why it's doing it, but it could be a very different, very interesting type of user interface. So are those the types of interfaces? Are those the types of user interfaces that we're going to be building in the future as software developers? And what does the tooling look like around that? And then the final thing, again, from an LLM standpoint, is these are non-deterministic systems, just like we're non-deterministic, except you can do thousands and thousands of them at a time. So what does it look like to say, I have a problem, solve it 10,000 times, and show me the best ones, and then I will decide from there, and we can iterate on this system. So I'm going to leave you with this, the last thing. I did title this Open Source 2.0, and I did not talk about open source this entire time. So I apologize for this, but it all kind of leads to this concept of open source. What is open source to me, right? I helped launch, build, and grow GitHub.com. I think most of us probably use open source from GitHub.com or open source projects that are hosted there. I think GitHub has really changed the landscape of open source. The open source of 15 years ago when I started is much different than the open source today. Today, I think you can any of you start a new project, you start putting 10 lines in a gem file or an NPM file or something, and say, hey, generate this. It pulls in hundreds of thousands of lines of code, 50,000 lines of code, whatever. Like, you have a starting point that is not reinventing 1,000 wheels, right? That is what open source is doing. But I think everybody in this room writes software using open source, builds on systems that are based on open source, on Linux, on Kubernetes, on all of these open source systems. But one last raise of hands: how many of you have opened a pull request to an open source project in the last week? Okay, so let's say 5% of you, right? So everyone in this room uses open source. 5% of you contribute to open source regularly. So what can we conclude from that, right? That you're all horrible people. It's fine. It's fine. I am too. But the problem is that it's easy to blame. It's easy to kind of do that kind of blaming thing, but it's not that you're horrible people, right? It's not. I haven't done it either, right? I kind of lean on the fact that, ProGit is open source and people take advantage of that without me having to put more work into it. Or, I helped build GitHub and that helps the open source community. But in a real way, I'm not contributing to open source on a daily basis anymore. And I feel a little bit guilty about that. So what is interesting, though, is to figure out why that is, right? Is it because you don't want to? Or is it because it's too hard, right? The friction is too high. And I think it's the latter. I don't think it's that nobody in this room wants to contribute to open source. It's that you don't have the time, right? You don't want to deal with the overhead. Open source is a very large, at the smallest level, you really have to open source something relatively large. You can't really open source a function. You can't really open source a verification of something that LLM spit out and you fixed it, right? Everybody has to fix those wrong outputs over and over and over again. I think to open source something, you have to have a whole library that somebody can pull in. You have to have a whole project that somebody can base something off. And that's too high of a bar. I think open source 2.0, with these generative tools, what I would love to see is something that it's more towards snippets, right? It's more towards function level stuff. Like maybe we have, again, frameworks that are built on hundreds of thousands of small functions that are all composed, right, in a way that is difficult for humans to manage, but it's easier for these types of tools to manage. Then is open source, I'm just going to help out with this one function, right, or this one fix, or this one verification, and contribute it back to a global database that we can all do. And then what if we're all doing that every day, right, even with private code, because it doesn't matter, you can open source one function out of private code if it's not super specific, that's fine, right? Like help everybody else not have to do that thing again. That's the whole point of open source, is to be able to stand on everybody else's shoulders and hopefully contribute back. So I think that systems like this, tools like this, moving away from the way that we're writing source code today to something that's more modular and more composable opens up a new world of open source that I think would be massively better, mostly because more of us are contributing to it. Right? It's more of a global sort of hive mind of let's not all reinvent the same thing at a much more modular level. So that is pretty much everything that I have for you today. I want to leave you with questionnaire tools using first principles, and being easily frustrated with things. And I look forward to seeing you guys in the future of software development as well. Thank you very much.
Thank you, Scott. That was great. Actually, I mean to say, I'm an awful person too, because I also have a project in GitHub last week, because my boyfriend wanted to buy a new property, and he told me, write a Python script and select from all the pages around which is the best option for us. So he said, you're a developer, you should write it to me. So I write it. I created also Jira to follow the process. And there are many awful people around us. So, not for work, using these open source projects for daily tasks.
Yeah.
For simple daily tasks. So we have some questions for you from the audience. Just a minute.
Horrible, horrible, horrible people. We are just taking code, never giving up.
Hashtag horrible people, if you guys are on Twitter.
Yes. This would be our new hashtag for the open conf.
So the first question is the $1 million question. Is AI going to replace developers? What changes do you see coming in the developer role?
Yeah, so this is a great question. I don't think AI is going to replace developers in the way that open source hasn't replaced developers, but it writes a lot of code that we used to have to write, right? Like I think any new advent in efficiency of producing software, it just changes a little bit the role that we have as software developers more towards what is taste, right? What is fast? How do you verify something? How do you figure out what to build? You still have to, even though there's code generation, I think you still have to figure out what it is that you actually want to get out and how it's supposed to work and how it's supposed to be useful to people. And that's still the hardest thing. You can have, we see startups every day, right, where they have very, very smart, very, very capable developers working on them, and they fail because they can't find product market fit. I think what's useful to us as developers is figuring out what we want to build, and that what we build is useful to people. And it doesn't really matter quite as much how exactly, right? In much the same way that it doesn't matter if we're using Django or Rails or Node or whatever the framework, you can build kind of the same things. It matters what you build, not how you build it. And I think AI is just going to help us be a little bit faster in doing stuff faster, like standing on more shoulders the way that open source has. Again, developing is much different 15 years ago than it is now because we have all of these things that we don't have to write everything ourselves all the time. We have so many more libraries and frameworks to work off of. And so I see AI being that, right? We're all just going to be able to produce more faster, and the $1 million question is, what are you building, and is it valuable for people?
And apart from that, isn't that a skill that the software developers need to be reskilled on using AI tools? Because you need to write some scripts, you need to write some props, storytelling
I think,
skills.
part of it is product development. The other part is verification, right? Like it depends on, like AI can produce a lot of things. This is kind of the point of the open source 2.0 thing is AI produces stuff, and you have to, AI, by definition, is going to be the mean of all of the code out there, right? It's going to be the average. At best, it's average. It's not going to do anything fantastic. because that's not the bell curve of the code that it's being trained on, right? And so you have to have taste in, okay, this thing is right, or this thing is the right way of doing this, or this is the right approach to it. And sometimes it can surprise you and do better than you would have done, but it's always good to be able to know what you're looking for and then have it produce it so you don't have to actually write every single letter. That's at least how I'm starting to use it, and I think how a lot of us are using it is asking Copilot or whatever for something, but then you can say, no, that's shit, or you can say, yep, that's actually more or less what I want, I'll make some changes. And I think it's going to be more about like an editor, like a author editor, right? Like, you don't have to write everything, but you have to have taste in what is produced.
But again, from my perspective and from what I understand, AI is not probably ready yet to produce quality code. But what happens if I introduce some code to it, which I think that it is great? What happens the next time I ask it? So wouldn't be AI in a better level to give me some insights at least?
Yeah, from a specific it depends on the systems that you're using. Actually, I don't know if everybody's seen the GitHub workspace stuff that was announced a couple days ago. I find that really interesting in that it's multiple steps. It's almost like a lang chain. It's like, okay, here's the thing, explain what you want to do, then create a plan off of that explanation. You can edit it kind of at everything, and then here's all the files you probably need to edit because it has embeddings for your specific code base, and then it gives you some suggestions, and then you say, yep, that looks relatively right, or it doesn't look relatively right. So I think editing will probably go, in the short term, more down that path. But you can also say, nope, this is all crap, and then write it, and then have it kind of give you some feedback, check it, or something like that. But I think it'll have different roles, right? It's just going to be about what is a language model good at versus what is a human good at. I think a human has taste, and a language model has a lot of information. And so it's always going to be a balance between those things.
So at the end of the day, AI will just make some chores for us.
Yeah. I mean, again, like I think it's about anything where you have something that has all of the knowledge in the world and can generalize it very well, but with no particular understanding of that thing. And I think we have to look at all the tools that we have and figure out what does this make sense for and what does it not make sense for.
Awesome.
So part of the second question was that answer you just gave us. We have time for this one. How could we motivate people to contribute to open source projects?
I mean, it's a fantastic question. I don't really have the answer to that other than I mean, honestly, I know there's actually a big debate now about training models on open source because some people view that as Microsoft is stealing my code, or kind of OpenAI or whatever is stealing my code, or that doesn't apply to the license. And I think it's very interesting to figure out what does that mean exactly, because like I have open source software, I have open source books and stuff that these things have also been trained on, but I open source them so that people can learn, right? That's part of what I enjoy about open sourcing stuff, is that I put the work in so that everybody else doesn't have to, and I kind of share alike in that model. And so I have no particular problem with that, but the motivation to do open source, I think, should be that, right? It should be I'm trying to contribute to a community in a way that is valuable to the community, and I likewise want to be able to take from the community so that I don't have to reinvent every wheel that I want to use. And so the motivation, I think, should be that the stick, or the carrot, I don't know, should be trying to build systems that reduce the friction for contribution. And I think GitHub and GitLab and like the sort of systems that we have now for sharing open source has really lowered that barrier of contribution in the last decade, and I'm curious what is even further lowering that barrier of contribution in the next decade look like. Because I think it's kind of stagnated for a while, right? And it's still the same bar that it was 5 years ago, even if it's much better than it was 10, 15 years ago. But like, I think it can come lower. I think what we do every day, we should have buttons that say contribute to the community, right? And that's how I think we motivate people, is just making it easy.
Maybe for everyday tasks as well, for not just related to work, for things you just have to face in the real life.
Well, so the other problem with that is findability. It has historically been findability, right? If you write a script for scraping a website or something that's taken something off of your plate and you want to share it so that not everybody else has to do that, I think that's great, except it's very hard to find. And so I think the other thing that LLMs help with is this findability, right? Is saying I can just ask a question and it can produce, even if it's not perfectly what you did, if it's close to what you did, it can produce something that it thinks can be what you want. And I think that that's actually closer to the spirit of why I'm open sourcing stuff, is to help people not reinvent a wheel. And so I like the idea that AI systems are trained on all of this open source, because I don't necessarily want exactly what you want. I want to be able to contribute the general understanding of kind of what I'm trying to solve to the general understanding of what it can pull from. And I find that useful. Sorry.
We could also dwell to the fact that a very large percentage of people who are writing code on the internet and online some of them are untrained. So probably this question that AI somehow will replace some developers' positions, or I don't know, goes also to that an untrained person who has no knowledge of coding can also have access to parts of code which can be generated, can be used.
Yeah, I mean, it's also a matter of I'll leave you, I know we're out of time here, but like, I think it's a matter of when we're talking about. Like, are we talking about today? Are we talking about 5 years from now? Are we talking about, 2 decades from now? Like, I think today, the way that AI sort of systems are really valuable in the developer, I don't think it replaces anybody, because the thing it does is not what a developer does. Mm-hmm. I think what it's good at doing today is it replaces looking up documentation, right? I think that's easily what I use it for 90% of the time, is saying I could go to the documentation and try to go through sort of the call stack and figure out what exact functions do I need out of which library and where do I find it and things like that. And I'm not doing that anymore, which is it's not replacing me as a developer, because there's not a role that's like some researcher or something, right, that you go to and be like, okay, well, tell me how to do this, and that person would do that. It's like, okay, well, you're not necessary anymore. Or even writing copy or something. Like, I don't think AI is very good at writing copy. It's good at doing very generic copy, right? It's good at being a bad copywriter, or an average copywriter, but it's not good at being human. It's not good at being interesting. And so, like, and I think it's the same with code. So I think today, nobody really has to worry about that. It just makes everybody a little bit more productive. In the future, I think it's going to change how software is written faster than it can sort of replace jobs, right? Like, it's not going to be the same jobs anyways. So it's not going to be like, here's the jobs that AI is replacing. So I think it's complicated, but I would not worry about it if I were you guys. Thank you very much.
Awesome. It was nice meeting you.
Thank you, too.
Thank you.
And this is for you.
Thank you very much. I appreciate it.
Scott also gives our closing party for today. So you are all welcome at the end of the conference today to join Scott, Gitbutler, and his team in the party. Thank you.
See you there. Thank you.